Picture this. It is the ultimate test of an engineer's mettle. It's 2 a.m., your pager screams that terrifying adrenaline spiking tone you literally hear in your nightmares, and a critical system is failing. Up until now, humans have had to rely on years of intuition and hard-earned experience to navigate that kind of chaos. But as the landscape of software engineering rapidly shifts, there's this massive question looming front and center over the industry. Are AI agents truly ready to handle complex, middle-of-the-night production incidents? Welcome to this explainer. Today, we're unpacking the rapidly evolving role of AI agents in observability. Based on insights from industry leaders, we're going to explore how AI is shifting the fundamental nature of software engineering, and we'll separate the hype from the reality as we go. Okay, let's dive into this. Here is our roadmap for today. First, we'll be defining observability AI agents. Next up, proven agent use cases. After that, we'll look at the name and chaos pitfall, then the missing mental model, and finally, we'll wrap up by solving the context problem. All right, Section 1, defining observability AI agents beyond the chatbot. To really wrap our heads around this, we have to completely move past the idea of a simple, single-turn conversational chatbot. A chatbot just responds to your prompt and stops. An AI agent for observability is so much more sophisticated. Think of it as a software harness. It combines a generative large language model, acting as its core reasoning engine, with specific tools and remote procedure calls exposed through an API. And this combination is a real game changer because it allows the agent to pursue complex multi-step goals. It can make a query, evaluate the results, realize, oh wait, my initial assumption was wrong, and then adjust its approach on the fly. It's not just answering questions anymore, it is actively investigating. Moving right along to Section 2, proven agent use cases, where AI shines today. So what can these multi-step investigators actually do in the wild? Well, this brilliantly illustrates how an automated incident response workflow operates. Imagine a priority 1 alert triggers for a high error rate on your checkout service. Notice how the agent doesn't just blindly ping an engineer and walk away. Nope. First, it queries the telemetry store for error rates and latency trends. It spots a spike right at 1432. Then, it autonomously fetches the slow traces from that exact minute. It identifies 3 distinct trace patterns and decides on its own to query the correlated logs from the affected services. Through that, it discovers timeout errors on the payment service attempting to reach the Stripe client. Finally, it actually looks up the retry configuration in your codebase, realizes the timeout is set way too aggressively at 2 seconds against a 5-second upstream SLA, and prepares a root cause summary with a suggested fix. You guys, it does all of this before an engineer has even opened their laptop. And that automated workflow, that's just one example. The proven use cases for observability agents today broadly fall into 4 main buckets: incident response, explaining errors and patterns in telemetry data, improving your code's instrumentation quality, and drafting service-level objectives, or SLOs, which, let's be honest, is something we all know is important, but nobody actually likes doing. Let's look a bit closer at a few of these. One of the absolute coolest, most underappreciated things an agent can do is act as a translator. Raw telemetry, like a cascading latency waterfall or a massive, overwhelming stack trace, requires genuine, hard-earned expertise to read. An AI agent can look at that exact same trace and instantly explain, in plain English, that you have a classic N+1 query pattern introduced by a misconfigured database mapper. It compresses hours of learning and tedious debugging into an actionable insight that literally even a junior engineer can immediately run with. Then there is instrumentation. Getting development teams to instrument their code well is notoriously incredibly difficult. Developers know they should add meaningful attributes and avoid noisy data, but in the rush of everyday practice, it just gets pushed aside. AI agents can operate continuously in the background, essentially acting as a specialized code reviewer. This completely removes the activation energy required to get good telemetry. It ensures your spans have the right context right at the exact moment the code is written. And finally, drafting service-level objectives. Teams universally agree, SLOs are crucial, but they almost always struggle to prioritize them. An agent with access to your historical performance data can actually step in and propose SLO definitions that are grounded in real, observed behavior. It can surface subtle trends indicating a service is drifting toward unreliability long before a pager-waking incident ever occurs. All right, Section 3, the naming chaos pitfall, the reality check. Before we just hand the keys to the kingdom over to AI, we desperately need a reality check, because the shiny, perfect promise of AI often collides head-on with the messy, patched-together reality of how our systems are actually built. As the source material bluntly puts it, naming is chaos in production. It is a universal pain shared by literally anyone who has ever had to maintain a legacy system. Think about it. Services get named by whoever created them at whatever random stage of a company's growth that happened to be. So you inevitably end up with user service, users SVC, and legacy user API, all running in the exact same system, doing somewhat related things. Now, you might know this, but an AI agent doesn't have a canonical map of your company's quirky nomenclature. And here is the danger. The agent is going to confidently draw the wrong conclusions from this misattributed data, and it will do so without ever flagging to you that it might be wrong. Section 4. The missing mental model, human versus machine. Now, what's really interesting about this dynamic is the core conflict between human intuition and machine dependency. A senior engineer operates on a vast amount of implicit knowledge. They understand the service topology, the critical paths, and the weird historical quirks of the system. They just know things. The agent's reality, however, it is entirely 100% dependent on explicit provided data. It only knows exactly what it can read in the machine data. To put this into perspective, think of an AI agent as a brilliant junior engineer you just hired today. I mean, they are incredibly smart, but they have absolutely zero historical context. The agent doesn't know that, despite its name, the service called Orders V2 is actually what processes the checkouts. It doesn't know that the telemetry from the inventory service has been partially broken since a messy database migration back in Q3, meaning those error rates simply can't be taken at face value. A human engineer implicitly filters all this out. An AI agent takes every bit of it completely literally. Which brings us to our final part, Section 5, solving the context problem, the paradigm shift. So how do we actually bridge this gap? Let's see how this builds out when we center the decision flow around operational context. It perfectly illustrates how context is the absolute determining factor for an AI agent's success. Starting at the top, you have business context, service topology, naming conventions, known issues. Now, if that context is missing, going down the poor context path, the agent defaults to generic queries. It gets an incomplete picture and delivers wrong or, at best, shallow conclusions. But if you provide rich context, well, the agent can run highly targeted queries, isolate relevant signals, and arrive at a highly accurate diagnosis. The AI model itself isn't the main differentiator here. The quality of your context is. Because of this, the day-to-day job of a software engineer is fundamentally changing. Actually, let me rephrase that. It's evolving. Your job is shifting away from direct execution, manually typing out every single query and tracing every log by hand, and moving toward direction. You are now responsible for setting the machine-readable context, rigorously reviewing the AI's outputs, and making those tough judgment calls at the boundaries where automation just cannot yet be completely trusted. So the crucial point I want you to take away from all of this is AI models are going to keep improving. For sure, the context windows will get larger and the reasoning is going to get sharper. But an agent will always only be as good as the machine-readable context you give it. Building that context layer, documenting the topology, fixing those messy naming conventions, codifying all your implicit knowledge, that problem is entirely yours to solve. The tools for an incredible AI-augmented future of observability are already here, and they are wildly powerful. Your AI agent is absolutely ready to take the pager. But the real question you have to ask yourself and your engineering team today is your context ready? Thanks so much for joining me for this explainer. It's time to start building that context layer today, and I'll catch you all next time.